Let's look at an example of the normal distribution and how to use the normal table. So suppose IQ scores are normally distributed with an average of 100 points and a standard deviation of 15 points. We're going to look at part A here, which is how likely is it to have an IQ score of 120 points or higher. A couple things to keep in mind: notation that's used for the normal distribution. The first number that gets written down is the average, and the second number that gets written down is the standard deviation. So in this case, my model is normally distributed with an average of 100 and a standard deviation of 15. For part A, I am trying to find the probability of having a score of 120 points or higher. My process for finding these is always going to be the same 3 steps. I'm going to draw a picture. I'm going to calculate a z-score. And I'm going to find that z-score by taking the value that I care about, subtracting the center, and dividing the standard deviation. And finally, I'm going to look this thing up inside of a table. Drawing my curve out here, the middle is my average. So in this case, I'm putting 100 down there. About halfway on the downswing, technical term is at the inflection point where it changes from concave down to concave up. But halfway on the downswing is 1 tick mark away, and that's what you're counting by for the standard deviation. So if you do 100 plus 15, this is 115 right here. If you do 100 minus 15, that gives you 85 here. And this is asking for 120, which is a little bit more than 1 standard deviation away, or more. So this, or shaded to the right. So I'm trying to find that area there. Now to find this z-score, and the z-score is the number of tick marks from the center. So I can already have a guess. This looks like it's 1 point something number of tick marks away. I'm going to take the value that I care about, 120. I'm going to subtract the center, 100. And I'm going to divide this by the standard deviation of 15. I'm going to type this into a calculator, and I'm going to see what I get. Looks like I am getting something like 1.33 or so. And I round this to 2 decimal places because when I use this normal table, it works like a grid. I have the first 2 digits of my z-score here, and the last digit of my z-score up here. So this is going to be in the 1.3 row where it meets the 3 column. And let's see what number lives there. And I want to be on the positive side. There's both a negative and a positive side to these z-score tables. And I'm seeing 1.3 meets the 3. That appears to happen at 0.9082. Now, as you may have noticed, the table here is shaded to the left. If I look at the other side, the negative side, it's still shaded to the left. So a couple of things that can happen. If your picture is shaded to the left, and it's going to be shaded to the left when it's less than or equal to some number, then your probability is going to be the value from inside of the table. If your value is shaded to the right, while the right is the complement or the opposite of the left, so that's going to be 1 minus the table value. And that's what I've got going on here. So this 90.82%, that's not the size of this tail. That's the size of everything to the left. So if I want the area bigger than or equal to 120, then I want 1 minus this value that I got in the table, which gives me 0.0918. In other words, 9.18% of people have an IQ score of 120 or higher. That's a very high IQ score. So left, table value, right, 1 minus the table value. Finally, if it happens to be between two values, so between some small value and some large value, find the table values for both of these numbers and take the large table value. The large table value is going to give you everything to the left of this number here. And the large value is going to overcount it. The amount that I don't want from that I'll have to take away is everything from here down, and that's the small table value. So if you have it between two numbers, find the z-score for both, look both of those z-scores up in your table, and then subtract those numbers. So again, left, table, right, 1 minus table, between two values, large table value minus small table value. Now you might be thinking, okay, so this is how I go from x values to probabilities, but how do I go in the opposite direction? How do I go from a probability, say the top percent of people, to recover my original x values? So let's say for part B, I want to find the top 10% of people. And I'm already pretty close to the top 10% on this last one because this was 9.18%. So I want 10% in this part of my curve here, and I'm trying to find this x value. Well, if I'm thinking about this, the top 10% is really the same thing as being better than 90% of individuals. So another way to really phrase this question of the top 10% is I'm looking for the 90th percentile. This problem's a little bit different because I'm starting out more with the inside area instead of the bottom x values. So here's my thought process about how I'm going to try to do this. Inside of my table, because the inside of your tables have this area, I'm going to try to find 90% on the inside. Now, from that value, I'm going to go out to see if I can find that z-score. And I'm going to pause the video for just a second, and I want you to see if you can do this yourself. Can you find 90% inside of your table? Okay, let's see how you did. So inside of my table here, I'm going to find as close as I can get to 0.90. So moving my mouse here, I see 89.8%, that's pretty close. I see 89.97, that's almost 90%. I'm going to go with this value. So going backwards to recover the z-score, this looks like this is in the 1.2 row, and it looks like it's in the 8 column. So I couldn't find 90%, but I found something pretty close to it, 89.97, and that was linked with the z-score of 1.28. So let's do some algebra to solve for that missing value. So everything I know so far, I have my z-score is 1.28. I know the average IQ score is 100 points. I know the standard deviation is 15 points. And I'm trying to solve for the value. Z-scores are equal to value minus center over standard deviation. So I'm going to plug all of my values in, and then let's do some solving. So my z-score is 1.28, so I have 1.28 equals. My value I don't know, I'm calling it x. My center or my average is 100. and my standard deviation is 15. And now I'll do some algebra to get x by itself. To get rid of this division, I'll do multiplication. So I'm going to multiply that 15 over. To get rid of this subtraction, I'll add the 100 to the other side. And this gives me my x value that I was trying to solve for. X equals 100 plus 1.28 times 15. Let's type this in and see what we get. When I do this, I get an x value of 119.2 points. So probably closer to 119 points, corresponds to the top 10% of IQ scores. So this is how to find normal probabilities and percentiles using one of these z-score tables.